Good morning to all. Myself Dr. K. Manovaran, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about digital clocks using 8051 microcontrollers. First thing, so we need to have a display unit to display the clock. So it should be displayed in the decimal format, then only the user can understand easily. So we need to display the information in hour, minute and seconds. So for each one we need to have two segments. So for hour, so two segments, and minutes two segments, and seconds we need to have two segments. So we need to have a real-time display that informations so that the user can easily understand it. So for interfacing it, we need to have an RTC interface, that is real-time clock interface. So we can get a direct information, that is a hour, time, delay, that is date, and all other information from the RTC interface itself. So by using this, just simply we can display the information. So if you need some delay units, or for example if we need some alarms, so we can have that alarms using RTC also. So for a digital clock, we need to display the information in a real-time manner of hour, minutes and seconds. So we need to use this DS1307. This is an high accuracy RTC clocks. So we can use a 16x2 LCD display for displaying that information. So sometimes we can use a 7-second display also. For an easy and impact, we can use this LCD displays. So again we need to maintain the time delay even during the power failures. So for that we need to use a battery backups. So 3.3 voltage battery backup that will be connected to the RTC clocks. So for a microcontroller with RTCs, we get an accurate digital timekeepings. Look at the hardware requirements. So first thing, we need to have this 89C51 microcontrollers. Again we need to have this DS1307 RTC with 3 volt battery backups. Again we need to have this 16x2 LCD display for displaying that information. We need to have a crystal oscillator for connecting resistors, capacitors and breadboards. And we need the power supplies. We can use a PCB to solve this general purpose, or a specific routers PCB also we can use it. Look at the block diagram. Look at this. This is the microcontroller. Look at this. This is the microcontroller, and this is the RTC, and this is the LCD. So here this RTC that will be connected to through these lines. So this is the SDA and SDL, that is serial data line and serial clock line. So we are using this I2C protocol for interfacing this RTC with the 805 microcontroller, because so for transferring that informations. So this RTC's information, the best is I2C protocol, because we need to have the time, again seconds, and then all other information like a day and year, month, everything we can get from RTC. So best thing is we can use this I2C protocol. So this is the pull-up resistor that will be connected to this port, and this is the crystal oscillator that will be connected to the microcontroller, and this is the output circuit. So this is the data lines that will be connected to the data lines of the LCD, and we have a lines. So that is then enable lines and then read write line. So these two will be connected here, and then we have this power supply control. This is the contrast control and power supply voltage, and that will be connected directly here. So this is the LCD control signal, this is LCD data lines, and this is the RTC connections using this I2C protocol. This is the crystal connections. So this is the reset button. So this is the general arrangements for the digital clocks. So first thing inside the program, what we need to know, we need to initialize the time for the RTCs. So today, date, time, seconds, everything should be written to the RTC one time. Once if you write it, this information will be kept always in the RTC. So once if you write it, so automatically the seconds will be increments, and then time, hour, minutes, also day and month, year, everything will be increments based on the information. So only one time we need to write that information. Remaining all time just we need to read the data, and the read data will be displayed here. So I am going to display only the hour, minute, second only. So get the data and send the data to the LCD. So this is the actual program sequence. Look at this program. So I am including this register 51.h. So for a header file for this 8051 microcontroller, I am including this I2C, that is I2C protocol header file, that is I2C.h. because we need to connect this RTC through this I2C protocol. include DS1307. So this is the header file for the RTC. So DS1307.h. I am including LCD.h for the LCD display. I am including that LCD. See, these includes will be useful for us to easily write the programs, because what are the function, everything we no need to do it. Just simply call the function, we can use it. Look at this void main. We are coming for the main program. So first I am going to initialize the LCD. So we need to initialize the LCD. So we have already learned this in the LCD display interfaces. So initialize the LCD, this is the first function. After that I am initializing RTCs. So DS1307 underscore INIT, that is initialization. So this initialize the RTC. So here the current date, time and all the information will be written in during this initialization itself. So while 1, so look at this, while 1 will be given here only. So initialization will be taken only one time, no need to initialize multiple times. Look at this. So main while loop, I first read in the time. So I get the time from the RTC. So it gives the hour, minute, second, every information from the read information. So once read it, I am going to display the information using this LCD. So I am calling function display time. So this is the format of hour, minute, second that will be displayed in the LCD. I am waiting for a small delay. After that I am going to repeat this. So continuously read that information from an RTC and update the information in LCD. So these only I am continuously doing it. So every second it automatically increments the time in RTC. That increments will be displayed in the LCDs. Thank you.